Hi, folks. I've just been informed that my audio was completely turned off. So yeah, like I said, well, you didn't hear me, but what I was saying earlier is that this is a complete process of discovery, and this is completely new for me. So I've never streamed YouTube before. This is the first time, and so I'd like to welcome you along for the ride. I have no idea what to expect. I have no idea how it's going to go, but we're just going to be having some fun with it. So. What I've got here is a graph of the Hebrew Bible looking at genre, and this is something that I did on Friday using the ETCBC data. And the ETCBC is a research organization at the Vrije Universiteit Amsterdam, and basically they put out data on the Hebrew Bible. And what's really cool about this graph is that you can see all of these different genres portrayed for the entire Bible in color in all of these little squares. So, for instance, red is prose, and we see that the book of Genesis, for instance, is mostly prose. And if we zoom in a little further, we can see that there are some, of course, narrative parts. This is Genesis 49 at the end of the book. So, a lot of cool stuff that we can see from this graph. And basically, the way that this graph works is that each sort of line is a pixel. And what we do is each pixel, in this case, corresponds with a verse that's been tagged with a certain type of genre. So I had the idea, what if we kind of did something similar? Instead of doing some things verse by verse, what if we looked at clauses, and what if we looked at different features in clauses? So that's the other graph that I've got here. And this is looking at what we call domain in the database. So let me just move this over so you can see it a little better. So domain refers to narrative, quotation, and then discourse is something that's, it's not direct quotation, but it's kind of like quotation in the way that the verbs are used in the text. And each one of these little strips is a single clause. So you can see there's quite more. So all this to say, here's the idea I have for today. Basically, I want to make a graph like this, except instead of doing narrative, quotation, discourse, let's just take this code and let's make a data set that looks at verb type instead, or clause type in this case. So what types of clauses are in the Hebrew Bible? Well, we'll look at that. We'll get into that question, and we'll build the data set. And so, yeah, let's get started. The goal is to make a graph like this for verb types, and we want to see vayiktols, or the vav consecutive. We want to see yiktols. We want to see katals. We want to see how these things are distributed across the Bible. So let's go ahead and get started. Let's fire up the engines. So I've got my terminal here, and I'm just going to launch Jupyter Lab. And I don't remember what I had up previously, but we'll see. What takes a minute to get started, and then now we're up and running. So I'm doing a lot of this work as part of a sub-project here in Cambridge to revise Gesenius's Hebrew grammar. So actually a lot of this work is nested under that project. So I'm going to go ahead and navigate to the folder that I've got set aside for the Gesenius project, which is under, let's see, we're under GitHub, Cambridge Semitics Lab, Gesenius data. In fact, if you want to kind of follow along, see what I'm doing, if you go to GitHub, and you go to Cambridge Semitics Lab like this. So GitHub/Cambridge Semitics Lab /Gesenius data. You'll see the repository here that I try to keep up to date with all of our latest code. Some of it is private, so unfortunately some of the data is not open. But I try to put out as much of it as I can there so that it's as fully available as possible. So Yeah, that's what we're basically digging into here on the Jupyter Notebook is the same data that's on GitHub with some exceptions. So I put this under analysis and under feature exploration. So let's go ahead and just open up that notebook and see what we've got. All right, and hopefully you can see I'm going to just make it a little bigger so that it will be easier to see. Let's see. First, I'm going to turn on the presentation mode, and then I'm just going to max it out a little bit. Hopefully you can see that a little better. So we're importing a lot of packages here. We've got just sys collections. I always import collections. It's just kind of, you've got great data containers with the default dictionaries and other things. NumPy, that's going to give us our matrices for doing matrix calculations. And of course, Pandas works alongside of that. Matplotlib to make our plots. And I don't think we actually use Seaborn in this notebook, but Seaborn is really, I love Seaborn. It's really fantastic. Besides that, we're going to be loading TextFabric, which is the corpus analysis tool that I use to access the Hebrew Bible data, and I'll kind of show you guys some examples of what that looks like. We've got the features here in a big feature string. So these are the inside of TextFabric. It's essentially a graph structure. You've got nodes and edges, and those nodes represent words, phrases, clauses, verses, and then on top of those nodes are features that are stored that you can access using TextFabric. So these are the features that we're loading, and we have a bunch of other TextFabric load statements, and essentially the main stuff we're going to be using to access TextFabric are these sets of variables here, FETL. We don't really use FS in this one in particular. I'm just going to get rid of that comma there so it doesn't treat this as a tuple. That would be bad. So let's just run this and let's get moving. It takes a minute to load the Hebrew Bible. There's over 400, my Siri's talking to me. There's over 440,000 words, so it takes a while to ingest it and get it going. So let's just get that, make that a little bigger, and maybe I can also get rid of this. We want to get rid of the tabs and everything. I just want to see a very simple let's see. I think what we want is single document mode, so that's helpful. And then I think this is good. So our code's loaded. When you load TextFabric, you get all these documentation statements that spit out at the end. Those can be silenced, but it's nice having the links there. I'm going to skip down past all this because this is basically what I use. This is just the code to build the data that I already showed you. And so here we're doing the narrative and quotation. In case you tuned in since then, this is basically this graph here. And one of the things that I had to do is I had to assign an integer value or a decimal value to each of these categories. Let me move this down a little bit. To each of these categories here, N, Q, D, and basically, I'm just gonna make myself a little smaller. Basically, these categories, I needed to assign them a number so that they would get assigned a color, and I used Matplotlib color scheme to do that, and this is the output. But yeah, we're doing clause type. A clause type or verb type. So let's just get started with it. I'm gonna open up a new section. And ideally for this, because basically what each of these plots are is there are a bunch of subplots. So for each book of the Bible, I'm adding an axis to the Matplotlib object and plotting each book individually. And so this is actually a big loop that happens here. And ideally, I would put this into a function so that I could just arbitrarily add things. But I'm going to do the shortcut here and just literally copy copy the graphing part, and we'll adjust it in just a minute. So let's get our data set down first. So what we need to do is we need to iterate through the Hebrew Bible through each book. And for each book, we want to move over every single clause and look at what type of verb is the head of that clause. I think we should skip clauses that are not main clauses. So I've got a little function that uses some of the database features to sift out the non-main clauses from the main clauses. So we'll use that, and I'll show you an example of that. So how do we do this? Well, first of all, we're going to want a dictionary where we can map our features to. So let's just start off with something like book to, I don't know, verb types. That's kind of long. Book to verbs. I'm going to make this a collections dictionary, a default dict. Because I don't want to have to say every time, if book is in dictionary, do this. I just want to say, just drop it in there, please. Thank you. How do I go through the clauses? How do I go through the books? Well, in Text Fabric, which I've got loaded up the F class here, I can say, I'll just show you an example. Let's make a list. I can say F otype.s. So we're looking for a feature. In this case, the feature is called otype, which it means object type. So we're looking for a object type, in this case, of a book. And let's see. And S is going to return a generator, so it's going to just kind of loop over all of the books. But we have to tell it what type of object we want to loop over. So in here I could actually put clause. I could say go through clauses, or I could say go through the words, or go through the verses, and it would return a list of verses. Let me get rid of this. But we want books, so let's do book. And I'm just going to show you what this looks like. So we get out a bunch of integers, and each one of these integers corresponds with a node number. It's basically a node identifier that represents a book. So how do we access features on these nodes? Well, we can take an identifier. I'm just going to copy this, and let's just experiment a little bit to show you. I'm going to use the F class again, and except this time I'm going to call a feature value. So here we were doing a feature search. We were searching for objects that had a feature, an O-type feature called book. Now we're looking for nodes that have a book feature with a value, and I'm just going to drop that node from there, and we see that there's Genesis. So this is essentially how we access features on individual nodes. All right, so I can use this. I'm just going to take this and say for book in autotype.s book, and that's gonna send us through all of the book nodes, these little numbers here, and of course there's more than 10. There's 39. There we go. So we're gonna go over all that. Now, how do we get the clauses? There's another class in Text Fabric that we can use to do this. So I'm just gonna keep this example of Genesis. It's called the L class. And that means that that helps us navigate up or down within a node. So in this case, we're going from a larger object that embeds the book, that embeds smaller objects like verses, clauses, words. So that means that we're going down. So we want to say L down on this node, Genesis, and we're going for the clause. And I'll show you the top. And you see that these look very similar to what we saw up here. each of these numbers is just a unique identifier that corresponds with a clause. How do I know it's a clause? Well, I looked it up as a clause, but I can also prove that it's a clause like this. I'm calling a feature value again, and it's clause. But if I take one of these, do the same thing, now it's a book. See? So these are just numbers that there's a dictionary underneath the hood of all of this that assigns numbers to values. That's basically all we're doing. So we're going through all the books of the Hebrew Bible, and now we know how to look at clauses. So we're going to say for clause in l.d, and we're going to need to feed the book node in. So that's this. We feed the book node in, but we're looking for what? We're looking for a clause. Okay. Another thing, I want to go ahead and get the string name for the book. There's two ways I can do this. I'll show you what they look like. If we just do it like this, I can say f.book.v. I think I already showed you this one. And then it looks like this. But you'll notice the default book value is in Latin. So, yeah, that's Hebrew. I'm a Hebrew guy, so I don't do Latin. No. That's okay, because we've got this nice little function I call t. And what we can do is we say t.section from node. What does this do? Well, this gives us nothing, apparently. .v, this is the problem, of course. This is not the F class, this is the T class. So we're not calling a value here. We're looking up some section information. And the default for this is English, thankfully. And it comes in the form of a tuple, because if I were to give it a clause node, like this, I took this and I said t.section from node, I would get the entire reference information for that node, Genesis 1:3. So because these are book nodes up here, I'm only getting the book, because a book by itself doesn't have verse or chapter. It is a book, is the whole thing, right? So this is what I want, indeed. In fact, I could say up here, I want the English name, so I'm going to use this method. So I'm going to say book name equals t.section from node book. And I already know that these are tuples, single tuples. So I can just take the top off like that, the first item from that tuple, and that's the string. Okay, so now we come to the clause. We need to do two things. We need to determine whether the clause is a main clause or not a main clause. If it's not a main clause, we should just skip over and keep not run the code after that, because if we do, we're running a bunch of code for no reason. We only want the main clauses. So one thing I like to do with this is to use the continue function, the continue command. I don't know. What we can say, first of all, how do we know if it's main or not? This is most important. How do we know that it is main or not? Very good question. I've got a function that does this, made by a very good friend of mine, Martijn Nair, and some other people, fine people, from the Abe Telstra Center for Bible and Computer. And this is what it is. I'm importing it, clause relays, from clause relays. This is a custom function. So what does it look like? This is a very good question. Let me just navigate to this directory. And let me make this a little bigger for you guys. And gals, of course. And where were we? We were under analysis. Okay. And we were importing clause relays. But is this because... This module is not in this same directory, folks. This module is in this directory, in data. See, sys a path, so I appended another path. Python paths are weird. They really are. So actually I need to go back up and go to data. There she blows. Clause relays.py. This is it. Yes, Martin Nair and Mariana Cayenne. Thank you very much. This is fantastic. What is this thing? What does it do? Well, this function takes in a clause and looks at a bunch of categories that are... it's actually really complicated. This is one of the weird things about the ETCPC data is the clause relations. They have relations between the clause, which is cool. But it is actually really complicated. But basically each clause is given a number, an integer, a code, and that code corresponds with some function that the clause has and some relation that it has to other clauses. That's really the key, the relations that it has. Clause atom relation code, as you see right here, carc. So this function, it takes in a clause node, those numbers I was showing you here. Takes in one of these node numbers. Where is it? There, like one of these, and classifies it basically using those codes that I just explained. Here you see that happening. So if it's if the code is 999, if it's greater, if the clause atom relation code is greater than 99 and greater. No, less than 999 and greater than 499, then this type of clause is a subordinate adverbial clause. All right. And if the clause atom relation code is in this, I didn't know you could do this actually. This is really cool. This is oh, no, my bad. No, this is just set. Okay, this is just set. It said if it's 0 or 999, classify it as main. And you get the picture. So we've got different categories. We've got subordinate adverbial. So there's 3 different pathways for something to be classified like that. And we've got some main clauses and a bunch of other things. So I'm glad that I don't have to write this from scratch. But basically this thing spits out whether it's a main clause, a subordinate adverbial clause, or... subordinate attributive, I thought. Let's just see what the ones they are. That's subject note. There we go. Subarg, so subordinate clause that serves as an argument. So it's object or something like this. And a subordinate clause that serves as a modifier. These are relative clauses, share clauses, by and large. Basically, all of the sub-mod are relative clauses. All right, so that's what this thing is. That's what this import statement here from clause relays import in dep calc. That's this majigger right here, this thing. Yep. So let's test it. I called it clause relator. So I want to make sure I can do this right. Clause relator. I can't remember. Yes, there we go. Main. Let's try a few of these. Make sure that it works. Let's try 100 of them. Aha, see? Main, 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 main. Look, do it like this. And you can see, okay, this clause is main, this clause is main, this clause is subordinate argument clause. What does that mean? Watch this. We can do this. Next. Aha, kitov, right? Vaya Elohim kitov. That's what this is. He saw that it was good, that good. This is the argument of seeing. Ra'ah. All right, but that's what we need. We need clause relator. So this coming back to our code here, we want to say if the clause is not, let's say clause relay equals clause relator clause. And if clause relay does not equal main, just keep on going. Because, yeah, we don't need to run anything else after that. But if it is main, it will run the code. I really like this. Another way we could have done this is to say that if the clause relay is main, then do all this stuff, blah, 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 do all this stuff. I don't like doing it that way because this way, with the continue statement, I don't have to embed everything under an if clause all over again. So this way I could just say, if it's not what we're looking for, pass over it, just continue forward. And I don't have to give another indentation, which is fantastic. All right, we've come this far. We are iterating through every book, through every clause in the book. We have the book name. We have whether the clause is main. Now we need to understand the verb type of the clause. And this is a little bit more complicated because there's different ways that you could do this. And let's see. I do want to look at our options. So I'm going to pull up the documentation for the Hebrew data. I don't have it memorized, the location of this documentation, so I'm going to go to GitHub, HSVC BHSA. And I'm pretty sure the documentation is somewhere here. Voila. Where's the features? Features. Indeed, this is what I want. Okay. So here we can see all of the features on the nodes, individual nodes. And we're trying to get the verb type, right, of this clause. So I think what we need to do how many types of verbs are there? There's a lot, but the other thing is that there's also verbless clauses, and in poetry that's a lot are verbless. In the Psalms, for instance, for sure. So, by the way, if you guys have ideas, I watch the chat, so feel free to chat it up. Don't be shy. Okay, I think what I'm going to do is I'm going to do two things. I'm going to do it one way. I'm going to say, let's look for a verb. Thanks, Zachary. Let's look for the verb inside of a clause. And if there is a verb, then great. Then we can tag it as we can parse it, basically. We already have the parsing information, so we can look up its parsing value, essentially. And if it doesn't have a verb, we'll mark it as a verbless clause. Zachary asks, what's happening here? Good question. Zachary, I'm making one of these plots here using Python data. And this is an example of one of the plots that I've made for something else, where you can see clauses. Each strip is a clause, and an end clause is a narrative, something that's being narrated. Q is quotation. D is, it's like quotation, but there's no explicit speaker. So this is usually when like the speaker is actually the narrator speaking to the reader, and some other things. So it's really cool to see how these colors play out in the different books, like this. But basically, what are we doing here? Well, I want to do the same thing, but for verb types in the Hebrew Bible. So basically, what I would like to see for the book of Genesis, I would expect to see a bunch of vayiktal verbs, for instance, a bunch of vav consecutives. So I would expect a bunch of certain colors here for that. And for the Psalms, maybe we would see a bunch of colors for the verbless clauses, because nominal clauses in Psalms are pretty common. So that's what we're doing. We're making this kind of the same plot. We're going to use the code for the same plot. Here's another one that I did for genre. So prose, poetry, prophecy, broadly defined. I mean, the genres here are very loose. So we want to make a plot like this for verb types. And so that's what we're doing. So we have a loop here that goes through every book for every clause in that book. We're skipping over clauses that are not main clauses, so like asher clauses, things like this. And we're going to try to get the verb type on that thing. So yeah. Thanks for the question. All right. We need to get the verb of the clause. How can we do this? Well, I'm going to use a list comprehension for this. So, and I'm going to call features on the words inside of the clause to select whichever word is the verb. Yeah. So I'm going to say verb equals. Let's call this verb cans, like candidates. These are just candidates. They are verbs. They're not. We'll find out. This is word for word list comprehension in word. L.d, the clause. This returns the generator of words. If, you know, you can use ifs in list comprehensions. It's really fantastic. If I need this thing called PDP. What is that? PDP is phrase-dependent part of speech. So if it functions as a verb inside of the phrase / clause-ish, then that's what we want. If it was SP, then we might actually like select participles that are not functioning predicatively, and we don't want that. So we say if fpdp.vword is a verb, then we've got our verb candidate. All right, and now we know if if there's nothing inside of this, the inherent truth value will be false. So we can say if not verb cans, then clause type is, we could call it a nominal clause, or we could call it verbless. Let's just call it verbless. I think that's pretty clear. Maybe I do it. I always have trouble naming stuff like this because you want it to be short, but you also want it to be clear. It's kind of weird. So verbless. So if there's nothing in here, it's verbless. Okay, if it is something in here, fantastic. Else, else. The verb is the first thing in the list. There's not going to be two things in here, is there? I mean, this is one of the things, actually. A clause can have a share clauses. So, like, if I'm a main clause, I could have other... No, but that would be as a separate clause, so... I think this is safe. Let's find out, actually. Let's just make sure this is a safe assumption. I'm just going to say if the length of the verb cans is greater than 1, tell me about it. Raise an exception. Just the verb cans itself. I'm going to look at this. Let's run this and see what happens. There is some. Ooh. How might one search, Doug asks, how might one search for a structure like a chiastic parallelism, such as stem, PGN verb, noun phrase, matching stem and PGN, something like that? I guess you mean like if we've got, are you offering some suggestions there? Like maybe we could look for chiastic structure where person, gender, number agree and are sort of echoed. That's a really good question. I think you might need some semantic information to really do that well. So you need to know that like two words are related to each other in part A of a verse and part B of a verse. And maybe you could use vector semantics for that. If you Google vector semantics, definitely worth looking at. There's maybe some other ways of doing it. Those are some nice ideas. Looking for parallel stems. Yeah, especially if a lexeme is being repeated or something. Okay, so back to this. Why do we have... I'm just going to dig into this a little bit because this is a bit problematic for our assumption that we can just take one item. And I'm just trying to think about the best way to do that. I'm going to insert something here. Normally, I don't think we're supposed to use single letter variables, but when you use these variables over and over and over again, it's just kind of helpful to do so. What I'm doing is I'm going to instantiate this use thing, and that's going to let me dig into examples a little better and pretty print them so that I can see what's actually going on. So this is our clause that has two verbs in it. What the heck is going on here? Let's get the clause. Actually, let's just drop that in the exception statement. There it is. So, Vayhi mavdil ben mayim lo mayim. So where's the verb? Mavdil. It says that's a verb. I mean, it's a participle, obviously, but why is the phrase-dependent part of speech a verb? The part of speech would be a verb, but not the phrase-dependent part of speech. I think, let's see. Extra features. PDP. Yeah. It's saying it's a verb. Well, this is just interesting. So how do we separate this verb, from this verb? This is really frustrating. This shouldn't be, in this case, this is not functioning as a verb. It's really more nominal. And this it's a participle. This feature should not be verb. SP. There's another in the database. There's another feature called SP, which is part of speech, and that definitely refers to something. If something is a lexical item and its lexeme is a verb, that should be a verb. But PDP is supposed to be context sensitive, so it should classify this as substantive, as a noun, actually. We could just take the first verb anyways. I mean, in this case, that would actually be right. In most cases, it would probably be right. We could also say if I find two verbs, if I find more than one verb. Okay, here's the question. Do we have any cases where the clause contains more than one verb and yet there is no non-participial verb? In other words, can we just say anytime you find a participle as the second verb or the third verb or whatever, just take the one that's not a participle? Is that possible? Can we do that? Okay, I'm going to do something here to do a little experimentation on this. So we said if there's two verbs, two verb candidates, more than one. Let's see if there's more than two. Let's change this to two. Are there cases with three? That would be, I hope not. It's running. It's searching. Haha, none. That's really good. Okay. No cases where the database says that there's three verbs in a clause. That's great. We're stuck with the problem of two. So I think there's a pretty easy way to do this if this is the case. All right, let's say everywhere that there is a clause that has two verbs, are all of those cases where the second verb is a participle of some kind? Maybe we'll find some infinitives too. I don't know, but let's just see how to do this. We say for this is interesting. So we have to say there is a participle. Let's just say there is participle. False. And let's do a search. So for word, let's just call it VC in verbcans. If what we need is the parsing for the verb, and that's stored under VT maybe? Yeah, so if we go to verb tense, if we find PTCA, which is an active participle, or PTCP is a passive participle. So f.vt.v VC is in the set PTCP or PTCA. There is participle is true. So it runs that whole loop, and then if it's still false, now raise the exception. This will help us narrow down what we need to do with the logic here. Run it. It's running. I'm hoping for nothing, for no exceptions. Yes. All right. Okay. So this is good. So this means that anytime there is two candidates for the verb, we just need to weed out the one that's the participle, and then we'll get the main verb for the clause. So, that's great. So actually, I'm going to keep this if statement here, and we're going to say filter out participial, non-predicative. And we don't need this anymore. And actually, I'm just going to redefine verb cans. So I'm going to say, I'm going to use another list comprehension here. So word for word in verb cans, and then with an if statement to filter it out. If f.vt. The verb tense is not in that set. I tried to do this the fancy Vim way. I failed. Vim is hard. It is really hard. Okay. I don't need this anymore. So, there we go. And that means that we've filtered out. And let's just, for the sake of our sanity, let's do a sanity check. After we've done that filtering, let's make sure that verb cans still is never greater than 1. The length of it is still never greater than 1. If it is, raise an error, please, and tell me the clause, and tell me those offenders, what their names are. Haha! We have solved the problem. We have. So, don't need that. And now, all right, if you just if you've come in since I started and you're interested in what we're doing, we are making one of these graphs like this, except we're going to make it for verb types. So this one, for instance, just shows narration versus quotation, discourse. But we want one that says something like vayikto, katal, yikto, things like that. So that's what we're doing. And we're iterating through every book. We're iterating through every clause in every book. We're skipping non-main clauses. And we've now filtered out participial verbs to retrieve the main verb of the clause. And we say if there is no verb in the clause, then we tag it as verbless. And now we know what the verb is. The verb is here, and we don't know its tense yet, but we can, like this. I'll just call this VT, verb tense. Was f.vt verb. And the ETCBC data spits out these values for VT, and I don't like the perfect, imperfect. Because look at this. You've got perfect, imperfect, and then vayikto. What's up with that? Like, this should be katal, yikto. Okay, but then imperative, in participle would need to be kotel. Alright, but I just don't like that. So I'm going to change that, actually. I'm going to make a verb map here. And anywhere that it says it's imperfect, tag that as yiktol. Anywhere that it says it's perfect, tag that as a katal. There's one extra step I need to do for the katal, actually. I need to check that there's a vav behind it or not. Because if there is, it's most likely a vkatal, and it's functioning completely differently from the katal, right? It's future prophetic type verb. So I'll have to do that. But this is good for now. Another thing I'm gonna do, I'm gonna just map the passive and active participles together, because we don't care if they're passive or active. We just want to know if it's a participle or not. They don't always tag them as verbs, and no, this is the weird thing. In fact, I could show you a case. I could show you some examples of this with a little query. We want to find a case where a word has a VT that is it can equal passive or active participle. Yeah, its SP is verb, but its contextual part of speech is not a verb. This is just a string, and I'm putting a query inside of this query engine. So yeah, this is what I thought. So yeah, we found some cases. So you see like Romes here. The creeping thing. Every creeping thing. The Yodhe. The knowers of Tovoro. So no, that's the thing. That's what surprises me about it, Doug. Why the Mavdil? Why was that tagged as a verb? Contextually, I have no idea. But thankfully we've gotten rid of that problem. So yeah, and I'm gonna remap this. So I'm gonna call it VT2, and I'm gonna use that dictionary that I just made. Verb map .get, which is really nice. You can just feed it in, and then if it doesn't find something, just keep it as it is. Feedback in VT. Please. And thank you. All right, we're basically done with the data part. We need to check for one thing. If VT is a katal, yeah. If VT is katal and the word behind it, so how do we do this? In TextFabric, the words are numbered consecutively. The nodes that represent the words are numbered consecutively. So I can actually just subtract one to look at the word that precedes the verb, and that gives us the node number, and I can call a feature on it. In this case, I'm going to call a feature called lexeme, lex, and I'm going to say if it's W, vav, then this is a vkatal, and to tag it as such. Like this. Oops. Assignment, not eval. Yeah. So, okay, the other concern I have now is when with this plot and with this one, we didn't have that many values to color. We've got prose, poetry. Okay, 1, 2, 3, 4, 5. That's more than this one, but it didn't really matter as much here because like the prophets are all green, which is, maybe that's spurious, but that's how it is. But with this one, for instance, there's only 4. So one of the things I'm curious about is if we've got like 6 or 7 different, or 8 different categories, that's a lot of different colors, and that might be kind of confusing on this scale. So we might need to simplify a little bit, but let's just see how it turns out. I'm just gonna keep a log here. Unique verbs. Just gonna check on something real quick. Did I do this as a data frame previously? That's one of the things I did not. That's okay. So I'm doing it right. All right. Because if it were a data frame, I could just, after the fact, say, give me the unique values. But I'm going to put them here to keep track of how many things we're going to have to account for in the plot. And then we can simplify. Yep. So, yeah, now we can say clause type. And we'll just name it that. So that that gives us, that aligns this value with the verbless value. So, and now we can go ahead and tag it. So we're gonna say 2 things. We're gonna assign it by book 2, verbs. Let's change that from verbs to clause type, like that. Are inseparable lamed, kaf, beit, and hey, and vav always counted as words to themselves? This is Doug's question. Or is there a way to specify skipping them in the numbering? They are considered words, yes. I could skip them if I wanted by just skipping over it in the algorithm. It's actually really nice to have them. The one thing you have to look out for is if you've got, like in the Genesis 1, lachoshech, to the darkness, and the hey there, the definite article, is actually not in the consonantal text, but it is in the Tiberian pointed text, and the database includes it as its own word. So if you don't want vocalized articles in your analysis, you have to skip them yourself just with the code. All right, so book 2 clause type, and we've got the clause type. My bad. We need the book here, not the clause type. The book name. And remember, this is a default dictionary, and we said that it should instantiate lists. So we need to append to that list, and a default dictionary will just instantiate a blank list when needed. And we can just punch her in there. All right. I'm gonna zoom out a little bit, and we're done with this. And let's run it. It should take a while. Of course. This should be equals. This is to your question, Doug. You were saying the lexeme of that word is equal to W. That's one of those words. So this takes a little bit of time to run. There's a lot of words, a lot of clauses, but it's done already. So that's pretty impressive, actually. This is the power of Python and the tools we have today. It's fantastic. I want to do a little report here, so I'll say, just tell me how many books are in my data set, just to make sure everything is working out right. And the verb what was it? Unique verbs. And this is, yeah, that's a set. Yep. So I need length. Or clause types, technically. I'll do it like that. And then underneath that, I'm just going to print a tab character and the unique verbs themselves so I can see what we've got. You know what would be nice and very easy to do? You can just change this to a counter object. And instead of, we never added it to the set, did we? Ha! I was supposed to do it here, so that's fine. Unique, I'm gonna change this. It's not verbs, it's really types. Now we can say the clause type, just count it. This is nice, counter is, I like it a lot. We'll run it again, and while that runs, just update this. Instead of tab, I'm just gonna say most common, and this is again types. So there we go. It didn't really print that out cleanly. There. 39 books, 9 types. Ah, we've got some infinitives in there, don't we? I don't want infinitives in the data set. Actually. Because for some reason those clauses aren't being... There is such a thing as an independent clause that has an infinitive as its head, of course. But they're really not common. And this is just more noise. So let's just get rid of those. I mean, there's not that many, so they won't be missed. Most of them probably should not be tagged as main clauses, I would suspect. Look, some of them are constructs, so we know construct infinitive. You shouldn't be here. Why are you here? So let's just do this. Once we get all the way down to here, and we can say if VT2 is in infinitive absolute, just sorry, but you don't make the cut. And also look, our participles did not map properly. What the heck? PTCP, PTCP, PTCA to PTCP. Why? Why, oh Lord? What's going on here? Did it get mapped properly? It should have happened here in verb map. It should have happened here. VT. So that if it was PTCA, like this, PTCA, it should have become participle PTCP. Oy vey. I'm just trying to figure out what happened here. Why does it not map it properly? Oh! Aha! This is tricky. I should have never named it this. Okay, when I remapped it, I named it VT2, and when I assigned clause type, I gave it VT, as if nothing had ever happened. Maybe I probably should have named that something different, like really different, to be clear, but that's fine. So we fix it. There we go. Nice PTCP, imperative, vocatal, catal, yictal, vital, verbless. I still don't like that, but I like this nice little Norwegian null symbol thing. Fantastic. That's better, I think. That looks nicer. And actually, okay, there's not that many, not as many as I thought there would be. I mean, I don't have memorized how many verbs are in the Bible, different types, I mean, but like this plot had 1, 2, 3, 4, 5 values, and well, here we'll have 1, 2, 3, 4, 5, 6, 7, so definitely more. But I imagine the participle won't be that. I mean, there's not that many, so it's not going to clog things up too much. Same with the imperative. I mean, hopefully, probably what we're going to see are large swaths of nulls, nominal clauses, viictals, and yictals, and then some catals sprinkled in both. That's what I expect. All right, so we've got the data set basically ready. And what does it look like? Let's take a look, make sure everything's healthy. Let's look at the book of Ezekiel, just for mix things up. We'll look at the top 100 clauses in Ezekiel. And this is what they look like. A bunch of strings. Vaik, null, katal, vaik. Very cool. So that looks good. And just like we did with the genre, I needed to assign an integer to each one, and that, or decimal, whatever, and that is then assigned to a color using the CMAP. So CMAP takes in the decimal and maps it to, in this case, categorical colors. This is matplotlib, and you can go and see the documentation here about all the different color schemes. But basically what we want, because you could do sequential color schemes, diverging, cyclic, but we have qualitative data, so we've got different clauses. So we want qualitative color maps, and I think I use set 1. That seemed to be the clear. So I'm just seeing if we use this set 1, we'll have to experiment, because we've got 9 features or so. Wait, what? How many verb types was it? 1, 2, 3, 4, 5, 6, 7. Okay. So it will be 1, 2, 3, 4, 5, 6, 7. Yeah, that should be okay. Hopefully they're all pretty distinguishable. But also I know that the order we make this dictionary in will kind of determine what order those colors are assigned. So we can try to make sure that the sort of bolder colors go to the more populous verbs. So in that case, then the null clause will give it, 0, 1, and the viictal, 0, 2, the yictal, 0.3, the katal, 0.4, imperative, and participle. So there it is. And this is not gen. So this is where we need to just book 2 gens. I copied this code from above, so let's just call it clausins. And I've got Vim on this Jupyter notebook here, so I can just say everywhere that you see gen, where is it? There it is. Ooh, yeah, gens. That's right. It should be book to clause type. So we can just do a command here from 1 to the end, substitute gens clause type everywhere. That seemed to have worked. We'll see. I'm sure there's an error somewhere, but we'll fix it in post. And I don't want to save a fig yet. I just want to wait on that. So yeah, this should do it, I think. This is going to be interesting, the big unveil. I'm about 90% sure there'll be a error somewhere to fix first. So let's just see how it goes, and then I'm going to run the cell. Here we go. Fingers crossed. Ha, there it is. Gen ints is not defined. That was supposed to be clause ints, so that's here. All right. Let's roll the dice another time. Book to clause type is not defined. Book to clause type. Book to, what did I do? I spelled clause. Tisk tisk. It should have been just CL. Book to CL type. And here we go again. Plot category is not defined. I do need plot category, don't I? That was up here. I need to separate this out. So because I don't want to run those cells right now. So I'm going to move this nice little function up here, run it so that it's in the namespace. All right, and I think we're ready. I think this could be the moment. Look at our colors. They're already lining up. They need to be smaller. I'll go ahead and do that. All right, everything seems to be go. No. Oh, what is this? Oh, guys, we didn't. Okay, one thing I need to do. Book to clause type book. Okay, so you give it the sets of clauses. Oh, is this something in that function plot category? Okay, it should be easy fix. Let's see. I'm just gonna move this down so we can fix it. Further, please. We're almost ready. We're almost ready to get the plot out. I think we're on the verge, but we just need to see. So this takes a list and an axis and CMap and a title. But the CMap is being mapped. Yes. This is the problem. So the problem is that we did not map yet the the clause identifiers, the tags that we gave each of the clauses to their integers. So we didn't apply this dictionary yet. So this should actually be here. We need to do that, if I'm not mistaken. Let me just double check. I'm gonna put a statement here. This is raise exception is really good for debugging because a print does not stop the code, but a raise exception will, and it will print. So I just want to look at the top 10 and make sure my assumption here is right. Yeah, see, these are all the strings. They should be integer. They should be the decimals that we assigned. And here, that's absolutely right. So this is the problem. This should be easy fix. So we just say the clause ints is the name of the dictionary up here. and we just say clause. This is a book, lists comprehension, so for clause in. And that should do it. This could be the moment. So here's our colors. They're lined up and ready to go. They're waiting. Let's run the cell. Let's see what happens. Come on. Come on, baby. Oh, this is good. No errors yet. Ah, here we go. It worked. It looks like Joseph's coat of many colors. This is cool. It is a little terrifying. But it's really cool. Like, look at Exodus. Vukatal, look at that. And the katal here at the end. Wow. Let's get a bigger version. Look at Joshua. Those verbless clauses. I want a higher resolution of this, so I'm gonna save it. This is fine, but clause type. I'm gonna save it. It's gonna go to my desktop, and then I'll open it up here. Just gonna wait. It takes a minute. This DPI is at 300, so it's a lot of pixels. Okay, this is actually cooler than I thought. I had no idea how this would turn out. And here is Joseph's coat of many colors. The colors are a little bit assaulting. Maybe we'll try some different ones in a minute. But what can we say about this? I mean, first of all, look at. Let me zoom in a little bit. We can see we can see some clear trends here, right? Let me just. Can you guys see this, or is it blocking the? I think that's fine. I just want to make sure I'm not too big. Sometimes my picture-in-picture blocks the graphs that you guys are looking at. But okay, so look, what can we say about this? I mean, look at Genesis. Compare Genesis with Judges, 1 Samuel, 2 Samuel, 2 Kings. Yeah. So they all have this kind of purplish hue. What is that? Let's zoom in a little more. Genesis. Where is that purple coming from? So the Vayiktal is contributing to a little blue. And the Katal. Is that Katal? Maybe this is part of the... No, that's red. So these are verbless clauses. You can see what I mean when I mentioned at the beginning here that basically the way that these graphs are being made, it's using the image plotting software in Matplotlib. And so each pixel, all I do is I plot one pixel of color, and then I tell the aspect ratio to just stretch that out. So it just stretches. So each one of these little lines is a clause. That's a clause. That's a clause. And this color, what is that? A peach. It's a brown, maybe. That brown is participle? Yeah. I did. This is really cool. Look at the Yiktal and Obadiah. But you definitely get more strong tendencies in Obadiah coming out because it's such a small book, right? It's easier to see than these that have thousands of clauses. But look at this. I mean, so we're talking about like what trends do we see? Like definitely see more blues-ish, more blue Vayiktals in the narrative books like this, with some exceptions. And then definitely see these brighter colors in the prophets. like Hosea, Joel, Amos. They're coming out as orange, so that's our vukatal, and yellow, that's imperative verb. Look at Isaiah. What is happening with Isaiah? It's mostly yellow. It's a very mixed actually. It's like what's interesting to me about Isaiah is it's not as brightly colored as these. Of course, one of the reasons these are more brightly colored is because there are so much fewer clauses in these books, right? So any sort of stretch of like the yellow here, which is the imperative, any stretch of imperatives are going to show up more brightly, more easy to see because there's just not as many clauses to look at in those books. So that's one thing. Wow, look at Psalms and Isaiah. Look at Psalms and Isaiah. Very similar profile. Just on a cursory analysis, they look very similar. And this is surprising. Look at Chronicles. So all this red here, that must be a lot of that is the genealogies, and that's what katal. No verbless clauses. A ton of verbless clauses at the front, some narrative in the center. The blue is vayikto, and some more verbless at the back. And then most of this stuff is blue, purple. Blue's vayikto, purple's katal. But it looks so much different than Genesis. It looks kind of similar, but let's see what different colors do. We can pick dark 2 maybe. Let's see what dark 2 looks like. And I'm not going to save, since it takes so long to save, I'm just going to set it to nothing over now. Dark 2. And just waiting. It's a lot of pixels to draw. Okay, this is definitely greener. Definitely greener. I'm going to actually just move the save statement down here so I can go ahead and run it while we look at the initial thing. I'm not sure which one I like better. I feel like almost like the original one better just because it was the first one to know. It's just really cool to see it come out. What else have we got? We could go for some soft pastels. See these, especially these, I would not think that would be good because we need definitely the cloth. Each one needs to have its own color for sure. In a future time, I think what a episode or whatever, what I would probably do is instead of using these color maps, is just use an RGB lookup, so I can get the RGB tuple, and then I could just assign like specific colors that I want, and then I'm not locked into these C maps. But for now, I don't think I really have time for that. I think we'll just probably stick with set 1, the original color. Let's try one more. Let's try tab 10. Those look pretty differentiated, so that might actually be better than set 1. A little more orange than red though. See, I really like the blue-red scheme. That's the thing. Tab 10. So let's see what that guy looks like. I kind of like the green. The Vayikto, like this actually seems to show the tendencies a little better. Let me run this. Let's put this up next to the genre. Because I posted the genre, where is it? This guy. So these are just kind of very traditional genres. I got a lot of hesitant feedback about this because people are saying, oh, you've classified prophets all as the same genre. Those are poetry. Of course they're poetry. They're also poetry. I didn't make these classes, but they have some validity to it. Let's see, how does the verb type compare with these very loosely assigned genres? Did it save? Is it saving? I do need to put this in the same. I wanted to move it down, but it won't do it correctly unless I put it in the same cell. So let's run it one more time and then compare the two. Almost done here. I'm going to finish up in probably about 5 minutes or so, 10 minutes. But I just want to see this comparison. So there, it's done. Saved it. And let me just, one sec, I'm just going to move myself off screen real quick and put these up side by side. Yeah, I mean, let's zoom it out, get the full picture. So, what can we say about this? Obviously, the narrative books are green. The prose books. So, the red on the prose side here definitely lines up with the. Let me try to put these a little closer. Definitely lines up with the green on the clause type side. So, that's true for sure. Let me make this a little bigger. What else? Deuteronomy looks surprisingly like the prophets. This is potentially. Here's another one. So, my very good friend Chip Hardy was saying that Jonah in the genre looks very much like Joshua, for instance, or Judges. And actually, you kind of see that here, right? You see the Vayikol sprouting green. It looks totally different from the other minor prophets. It really does. Okay, what about the poetry versus prophets distinction? Is that merited? The green prophets, the blue poets. Not really. I mean, the thing you have to remember, again, I keep saying this, but the reason that these look so much different from, for instance, Psalms, etc., is partly because there's so much fewer clauses. So you get these like stripes that run together more easily, like in Obadiah. Of course, it's such a tiny book. And that's just because it's tiny. It's not because there's a real fundamental difference here. So I think the deal is that what does the jury say about this? I would say the main separation here looks like narratival books / prose books. Genesis, Exodus-ish. Leviticus definitely not. It's different, right? There's a lot of Yiktul, some Vukatals, brown Vukatal. It would be nicer to do this with more distinctive colors, but I think this is pretty good. I think this is good enough, at least. Chronicles looks different, for sure, from the other types of prose books. The beginning of Chronicles, there with the genealogies, definitely looks different. So yeah. I think, guys, this is basically the end of our road here. We have plotted clause types throughout the Hebrew Bible. We went through every book, we classified the clauses in every book, and we plotted them. And we could improve this maybe with some sharper color differences, but at the end of the day, you're still going to have a mixture no matter what. And this at least allows you to kind of see the tapestry that is the Hebrew Bible. So I will push this to GitHub and post the links to the code and to the images. And yeah, I think that's something that, in fact, I will do it presently. I have this handy little shorthand, get AC. Oh, I need to go into the data. All right, and I push it off. You can find it again at github.com / Cambridge Semitic Lab / Gesenius data. And that's where I put all the Gesenius, the analysis that's part of the Gesenius revision project here at the University of Cambridge. And it is, if you go to analysis and you go to feature exploration, you'll see the code there. I should add, if you're going to run this, there's going to be some issues with the paths that you'll need to work through. Just send me a message if you need help with that or whatever. But yeah, you guys have a good day. Have a good Saturday. And gals, have a good Saturday. Thank you for watching. And until next time.